Hi friends, sorry about the part two, but sometimes lessons just, work out better if you do it in two parts. So hopefully you tried some problems in section 6.3, and we're going to be able to finish off the problems now as we look at some more information. So remember, we were talking about dimensional analysis. We looked at stuff that we should know, and we had a problem where we did some dimensional analysis and we did a little bit more where we had to convert the numerator and the denominator. Here's some handy conversions that we need to keep in mind, and I will provide you guys with a physical copy of this. It is in the textbook. I don't think I put it in the packet, but there's a copy of this. And what you're going to notice is that when it says customary, what we're talking about is the U.S. general U.S. measurement systems. So we are dealing with 1 inch, feet, yards, miles, fluid ounces, pints, quarts, ounce, and pounds that are particular to the United States, but the rest of the world, or the majority of the world, uses a metric system. So oftentimes it is really, really helpful to have these conversions. So notice if you're going from metric, if you're going from customary, our customary, to metric, you'd want to use this side. If you're going from metric to customary, you want to use this side. So we can kind of talk about this a little bit more as we apply it to a problem. So let's take a look at this next problem. Example 3, it says convert the measures. So we're going to complete each conversion. We're going to round to the nearest hundred. So when you see something like that, generally you're going to be using a calculator, and you might get a little bit more difficult to deal with numbers, and calculators are okay here. So 12 centimeters to inches. So I'm starting off with 12 centimeters, and I eventually want to go to inches. I like writing that down. Sometimes it takes more than one step, but if I go back up to my conversion chart, I see that, oh, by the way, the wavy lines means approximately, not exact, but for all intents and purposes, we're going to use equal signs, but this is the right mathematical way to put this. So if I start off with 1 centimeter, I know that for each centimeter, it is equal to 0.394 inches. So in a way, this is like a unit rate, right? Because 1 to something else. So I could put 0.394 inches over 1 centimeter. How does that work here? Well, I have centimeters here, and I want to change them to inches. So in a sense, when I use this rate right here, when I use 394 thousandths of an inch is equal to 1 centimeter, I can write that out like this: 394 thousandths of an inch is equal to 1 centimeter. So we have a conversion factor because they are equivalent. These guys will cancel each other out. So the centimeters go away, and I'm left with a certain amount of inches. I don't know why I have 1 there. Let me erase that because that looks crazy. So my answer needs to be in inches, and that's what I'm going to get. Don't like red. That's what I'm going to get. So handy dandy calculator, pull it out, multiply 12 times 0.394. I get 4.728 inches. They asked us to round it to the nearest hundredth. What space is the hundredths place? Tens place, hundredths place. So we're right here. We need to round to the nearest. We remember when we round, we're either going to go up or stay there. We're at 2. We can stay here, but the next number tells me that I need to go up because it's greater than or equal to 5. So my answer is 4.73 inches. Make up about 12 centimeters. Sorry about that. Okay, so now we've got to go from, let me erase some of this stuff here. Now we've got to go from quarts to liters, and I hope you guys recognize that quarts is a customary, that we're used to using quarts. Liters, we do talk about liters actually, by a liter soda, but that's a metric measure. So when I go back up to my chart, I'm looking for customary to metric, and I found it. It's right here. I see that I've got 1 quart to 0.946 liters, which shows me that a quart is about equal to a liter, right? A quart is almost equal to a liter. A liter is a little bit greater, as you can see. All right, so let's use that information to solve this problem. So I'm going to write it down here. 1 quart is equal to 0.946 liters. And so if I start off with 4 quarts, the conversion factor that I'm thinking about using, remember I can have liters over quarts or quarts over liters. I'm going to put my quarts over liters. I'm going to put my liters over quarts because I want to cancel out my quarts. So I have 0.946 liters over 1 quart, and my quarts cancel out, And the simple thing that I need to do is multiply it together. So 4 times something close to 1 is going to be pretty close to 4. So my expectation when I calculate this, and this is just us thinking about what we need to do, is that I get an answer that's pretty close to 4, and I do. I get 3.784 liters, because that's what we were converting to, and we saw that we handled everything well so that our quarts canceled out. And now we're going to do what we did last time. We need to find out what the nearest hundredth is. 8 is in the hundredths place. We will either stay there or go up, and we're going to stay there because 4 isn't greater than 5. So our answer is going to be written as 3.78 liters for this example. Let's look at example 4. Example 4 is asking us to convert rates between systems. Again, so we've got a giant tortoise that can travel 900 feet per hour, and we want to determine how many centimeters per second the tortoise can travel. So you see, this is one that's going to be kind of involved. Let's get started organizing our information. So we are starting off with 900 feet per hour. I like to put it down. I told you guys before, I like to put down my goal. Determine how many centimeters per second the tortoise can travel. So I'm looking at centimeters per second. So I got a lot of changing I need to do. My feet need to change to centimeters, and my hours need to change to seconds. Well, we've already done an hours to seconds conversion, so we know how to do that. The feet to centimeters is something that we haven't done. So what I'm going to do is I'm going to suggest let's do our hours to second conversions. So from the last problem we did, we saw that 1 hour was equal to 60 minutes, and then we went from 60 minutes was equal to, oh no, not 60 minutes, sorry darlings, sorry, I got away from myself, not 60 minutes but 60 seconds. Let me see if I can take each one away. Okay, so let me do it this way. 60 seconds is equal to 1 minute. And so what I did is I was able to create conversion factors. Remember, I would put 60 minutes over 1 hour, or 1 hour over 60 minutes. Well, if I have an hour, I'm going to now try to break it down into minutes. So I'm going to put 1 hour over 60 minutes. That's the conversion factor I'm going to use there. But so that when I use that, my hours are gone, and now I'm a little bit closer to seconds, but I'm not exactly where I want to be. I'm now going to take my my other conversion factor of 60 seconds to 1 minute, and I'm going to put 1 minute at the top and then 60 seconds at the bottom. So now you'll see that when I multiply this through, I'm good to go with the seconds department, but I still need to deal with the centimeters. So I've got 900 feet. How do I get to centimeters? Let's go back to that other chart. So when we come back here, we are going to look for a relationship between feet to centimeters, right? And if I look, I don't really have it. I don't have a feet, 1 foot to meters. Well, a meter is really 100 centimeters. I don't know if you guys remember your metric conversions, but 1 meter is 100 centimeters. I can think about it that way. Or I can think about feet to inches, which I already know how to do that. And maybe I can go from feet to inches to centimeters. I'm going to try that path. There's more than one way to do these problems, but this is the path I'm going to try to choose right now. So I know back here that I need to go from feet to centimeters. But first I'm going to go from feet to inches. So I know that 1 foot, and this is just information that I expect you to know, 1 foot is equal to 12 inches. And then so when I use that, I'm going to put my 12 inches at the top and my 1 foot at the bottom. This is equivalent to two values that are equivalent, so it's cool for me to put them over top one another. The feet cancel out. I'm now in inches. All right, I'm getting there. Now I go back up and I say, okay, here it is. 1 inch is equal to 2.54 centimeters. And I'm going to change my inches to centimeters by saying 2.54 centimeters over 1 inch. My inches will cancel out. Ooh, that took a long time, but we made it. We are now where we want to be. We've got centimeters, everything that's canceled out, centimeters are left, everything that's canceled out, only seconds are left. So now it's just a matter of me multiplying the numerator and the denominator. We're multiplying the numerators all together, so that's 900 times 12 times 2.54 centimeters is going to give me 27,432 centimeters, and then multiplying 1 times 60 times 60 times 1 times 1 gives me 3,600. And then when I'm done, I need to find the unit rate, right? And so as we do, we divide the bottom by 360 and I get 300. I'm sorry, I don't get 300 anything. I get 1 because I'm dividing the denominator by itself. I get 1. Then I do so for 1 second or per second. Then I divide this numerator by 360. And when I do that, I get 7.62. So according to our calculations, this tortoise travels 7.62 centimeters per second. Kind of slow. All right. So now, guys, you have seen enough that you should feel that you can attack all of the problems in our assignment section. Let me know. I do want to help you. I know that this is kind of complicated. I would expect this to at least take 2 or more days for you to get done the assignment. And I look forward to helping you. Have a good day.